we're going to start talking about matter. We need to know what matter is and how to classify it. The goal for this lesson is that you can use a model to classify matter based on its structure and its properties. So basically you should know the difference between a substance and a mixture, an element or a compound, different kinds of mixtures, homogeneous or heterogeneous, and the difference between atoms and molecules. Let's start by defining matter. Matter is anything that has mass and occupies space. And when we say it occupies space, that's another way of saying that it has volume. So basically anything with mass and volume is matter. Even a substance like air that we can't see has mass and it takes up space. We know it takes up space when you think about if you blow up a balloon, you put air into that balloon, it gets bigger, right? Well, it also has mass. If you were to take two balloons that had the same mass and put them on a balance, and then you inflated one of them, the one that's inflated with air would be heavier because it has more mass. That just proves to us that the air has mass, so it's matter. When we start to talk about types of matter and classifying it, the two main categories of classification of matter are pure substance and mixture. Matter that has a uniform and a definite composition is a pure substance. And when we say a uniform composition, we mean it's the same throughout. No matter what sample you take, it's going to be exactly the same as another sample. Now, a pure substance can either be an element or a compound. An element is something like carbon or hydrogen, oxygen. It's made of only one kind of atom. A compound is made of more than one kind of atom, something like water, which is H2O, or salt, sodium chloride. These are substances that, even though they're made of one kind of, or more than one kind of atom, they're the same throughout. So I could take a sample of sodium chloride from one cup and another sample, and they would be the exact same. The other important thing about pure substances is they cannot be physically separated. So that means that the only way to change them or to separate them is to actually have some kind of a chemical reaction. So they cannot be physically separated. If I have water, I can't physically separate the hydrogen and the oxygen atoms. If we're looking at kind of a model or a picture of what a pure substance might look like at the atomic or molecular level, this is what it would look like. Obviously, this is really zoomed in. But if you look at this example right here, just the blue dots represent atoms. They're all blue, whatever that atom is, they should be the same size. They're all round. So this is the same throughout. Pure substance of whatever that atom is. Right here, these green things, there's two dots together. Those represent molecules or elements, really. So it's more than one atom, but they're the same kind of atom. Whatever the green atom is, there's two of them attached. So it could be something like hydrogen, maybe. It could be oxygen. Any of those things, they're a single kind of atom, but there's more than one attached to each other. Okay. Now, when we're looking at this other example over here, the blue and the green combined, we have two different kinds of atoms that are combined. Those are called compounds. Now, they could be molecules, they could be ionic compounds, but they are a compound. So they are chemically combined. It will take a chemical reaction to separate them. And these are things that are also going to be the same throughout. So all three of these things here are examples of different ways we can look at pure substances, or different things that are pure substances. Atoms, elements, and compounds. The other major category when we're talking classification of matter is a mixture. With the mixture, we're physically combining, or we have the physical combination of two or more substances. Now, these are not chemically combined, so I don't have to have any kind of chemical reaction to put these substances together. That means they can be separated physically. I could filter them. I could pick out the 3 different things, separate them by hand. I can go through a physical process to separate the parts of the mixture. Now there are 2 types of mixtures. We have heterogeneous and homogeneous or homogeneous. We're going to get into those in just a minute. So mixtures are combinations of different things. It could be a combination of M&Ms and Reese's Pieces. It could be a combination of different kinds of minerals and things like that to make things like granite and concrete and whatever. It can also be, like we had our blue dots representing atoms and our green ones that were some kind of an element. It could be those 2 things mixed together to make some other mixture. And that mixture might end up looking something like this right here. So there's our mixture with at the molecular level. So I mentioned there are 2 types of mixtures, heterogeneous and homogeneous. A mixture that is not the same or not uniform in composition is a heterogeneous mixture. So that means that you're going to have components that are not evenly distributed throughout the mixture. So some examples of heterogeneous mixtures. Trail mix. If you ever eat trail mix and you take a handful of it, not every handful that you take is going to be identical because the mixture doesn't have the same composition throughout. If you look at the rocks in a bed of rocks, it's not usually identical. The rocks might be different sizes, different shapes, slightly different colors, different compositions, things like that. So as a whole, the rock garden or the rock bed is a heterogeneous mixture. Now, a suspension is where you have a mixture where some of those particles that are in there actually settle out if the suspension or the mixture is left alone long enough. If you think of things that you have to shake, those are usually suspensions. So sometimes medicines that you have to take that are liquids. Your salad dressing in the refrigerator, you have to shake that. Orange juice that has pulp, all that pulp settles to the bottom. Those are suspensions. The other type of mixture is a homogeneous or homogeneous mixture. That is a mixture that is the uniform or the same in composition. So no matter what sample you take, it's going to be the same. The components of a homogeneous mixture are evenly distributed, and they are not easily distinguished between each other. So that means that they're going to be really hard to tell the difference between them. We've also got 2 different kinds of homogeneous mixtures. The first one is where something is dissolved in something else. A solute is dissolved in a solvent. That's called a solution. So maybe you have salt dissolved in water. That's a solution. It's called a saltwater solution. The salt is our solute. That's what's being dissolved. The water is the solvent. That's what's doing that dissolving, breaking down those, separating the molecules as much as possible so that they are evenly distributed within the water. We also have something called a colloid. Colloids are solutions where the particles are kind of in between sizes. They're in between the size of a suspension, where the particles are big and they fall, or a solution where they're very small and they distribute evenly. So a colloid has those kind of in-between parts. So the biggest difference between the suspension, colloid, and solution is the size of the particles that are distributed within that mixture. In a suspension, they're large enough and heavy enough that they're going to settle to the base. In a colloid, they're not going to settle, but they're going to be big enough that if you shined a light through that colloid, it would the light wouldn't pass through. And in a solution, the light's going to pass right through. Those particles are really small. Some examples of different types of colloids. There's actually 4 different classifications, but some examples are things like fog, smoke, milk is a colloid, paint is a colloid. These all have particles that are big enough that they won't let light necessarily pass all the way through.